Welcome back to the another project presentation by 360DigiTMG. Today project presentation is a predictive agriculture analytics. So this project I'm handling to the team A. Deepak, please continue.
Thank you, ma'am. I'll ask our team member Aradhna to start our presentation.
Good evening, everyone. I am Aradhna. Today, my teammates and I are here to present Predictive Agricultural Analytics project. Go to the next slide. So before we are getting into the presentation, we would like to thank our project managers, Mr. Sarath Chandra Manikonda, Director at Innodetics, Raju Kalyan. Go to the next slide. Our project mentors, Emmanuel Mitra, Aspak Sek, and also 360DigiTMG for giving us this opportunity to present our project. Go to the next slide. These are our team members which were worked for this project. Nayan Soni, Girgani Pallavi, Akhil, MD Tariq, Subham, Dipali. Go to the next slide. Rahul Chavan, Rishi Verma, Muzammil A, Mohammad Akib, Far Sek, Ritika Verma. Go to the next slide. Aradhna Jit, Vanu Prakash, Challu Ravi Teza, Izzamam, Deepak as our team leader, and Anil Kumar. Go to the next slide. Before we are getting into the presentation, we'll have to understand that what is predictive agricultural analytics. One of the most exciting technologies presently being used and widely being transformed and developed has been the use of predictive analytics. Predictive analytics as a whole can consist of numerous different statistical abilities from modeling, machine learning, and data mining used for agriculture, the past on the crops, as well as what currently is happening and is going to happen, to make use the data to predict the future and make decisions that impact the bottom line and end use of crop products. This is from my side. Now I will take over from here to my teammate Pallavi.
Thank you, Aradhana. And this is Pallavi. Let us discuss about the content of the project. Project introduction, project overview and scope. Project
001 पे लिख के आ जाएगा फाइल में तुम्हारे.
Success criteria, CRISP MLQ methodology.
नहीं कर रहे हो गया पानी. भाई एकदम अबे की जला लिए क्या तो लेकिन मदद सोच क्यों अबे कहाँ रहते पे.
Technical stacks, project architecture, data understanding, data preparation, exploratory data analysis, model selection and building, deployment, future scope, and conclusion. Next. Next slide. And coming to the introduction, before slide. Agriculture is an activity which is directly dependent on the environment, availability of land, fertile soil, availability of water. India is one among the oldest countries which is still practicing agriculture. Nowadays, trend in agriculture has made a lot of changes due to globalization, various factors that affected the health of agriculture in India, and many more challenges to overcome, and also many new technologies have been invented to regain the health. One among such technology is crop recommendation. It suggests the farmer the right crop on their site-specific parameter. Recommendation of crop is one major domain in precision agriculture. Precision agriculture is a modern farming technique that uses research data of soil characteristics, soil types, crop yield, data collection, and suggests a farmer. The main aim of crop recommendation is to identify these parameters and recommend suitable crop at specific time. Next slide. Project overview and scope. To predict the high demand crop in upcoming session, if it done manually, is time consuming process. The main aim of this project is to recommend the best quality and high in demand crop in and around Hyderabad, which gives the most benefit from it. We are building this model to minimize the time for selecting the crops. Next slide. Project goals. The objectives of this project is to recommend the best suitable crop in that area with high level profit and good returns on investment. In the constraints, there is a lack of time to manually extract the best crop with good income for upcoming session. Next slide. Success criteria. The model recommends the best crop which gives a high accuracy, and this helps the farmer to choose the right crop at right time. It decreases the chances of loss and crop failure. Next, my teammate will take forward. Over to you, Deepak.
Thank you, Pallavi. For this project, we are actually using the methodology that is called as a CRISP-MLQ. In this, CRISP-MLQ stands for the Cross-Industrial Standard Process for Development of Machine Learning Application with Quality Assurance Methodology. In this, there are 6 main major steps which we need to follow, which we are using as a first business and data understanding. In this business and data understanding, deploying machine learning application starts with identifying the scope of the machine learning application, the success criteria, and the data quality verification. The goal of the first phase is to ensure that the feasibility of the project. Applying the machine learning canvas project as a project charter for a framework is a structured way to perform this task. Second steps, moving to the overhead, is like data engineering and data presentation. In this preparation, the second phase of CRISP-MLQ process, model aim to prepare data for the following modeling like data selection, data cleaning, feature engineering, and data standardization. These tasks are performed during this phase. With our second step, we move forward for the machine learning methodology or model engineering. The model phase is machine learning specified for the part of a process. This phase aims to specify one or several machine learning models to deploy in the production. Evaluating the machine learning models is a fourth part. Consequently, model training is followed by model evaluation phase, also as offline testing. During this phase, the performance of the trained model needs to be evaluated or validated over on the test dataset. Development is the fifth part. With machine learning model development, it includes the following tasks: interference hardware definition, model evaluation in the production environment, online testing that is, and providing user acceptance and usability testing. With the last stage which we are going is a monitoring and maintenance, which is one of the most important part. On this, once the machine learning model has been put in production, it is essential to monitor its performance and maintain it. When a machine learning model performs,
काय ते उदया म्हणाव घरी नाही कोण म्हणाव की त्यांना म्हणा माझी मीटिंग चालली आहे 9 वाजेपर्यंत मीटिंग आहे मी बाहेर येणार.
When a machine learning model performs on a real world data, the main risk in the model is the model stainlessness. That is, when it affected with an unknown data set, that has to be considered. This slide tells about our technical stacks. The technical stack delivers with our Python as an exploratory data analysis. That is also known as AKA EDA, is been used to model building combined with integrated development environment, also known as IDE, as an environmental development integrated environment development with Jupyter Notebook, Python, and Google Colab. The main libraries which we are focused and used are NumPy, as it adds a powerful data structure to Python that guaranteed efficient calculations with arrays and matrices, and it supplies an enormous library of high-level mathematical functions that operates on this array and matrices. Pandas is widely used on the data analysis and manipulation library for Python, which all handling of the data like alignment, indexing, multiple file formats supported, merging, joining, or etc. Matplotlib is the most popular data visualization library of Python. It is used to generate simple yet powerful visualization. SweetViz is an open source Python library that helps to generate beautiful, highly detailed visualizations to exploratory data analysis with a single click of codes. Scikit-learn, also known as sklearn, is the most useful and robust library for machine learning in Python. It provides selection of efficient tools to machine learning and statistical model. Seaborn is in a Python data visualization library based on a matplotlib. It provides a high-level interface for drawing attractive and informative statistical graphics. Using Streamlit, we can develop a machine learning model and any Python project with ease and without worrying about fortran. Moving on to the next slide with machine learning canvas. These slides actually tell us the flow where we have summarized the steps accordingly. By understanding the business problem and requirement of the user, data from different sources like government, open data sources, state data sources, journals, and survey all are being combined and made in a single platform to work for EDA in Python. After understanding the metadata, we did data integration, transforming the dimension, cleaning, and other steps. By using Matplot and Seaborn, we were able to visualize the data we prepared and were able to take interference from the further appropriate steps. We used further feature engineering or in our data to got connected with machine learning algorithm, for which we needed to select different machine learning models to check several parameters for the required output. Splitting the data over the train and test percentage, we train for the best outcome with the data. With satisfied testing of on a different parameter, selecting the model was performed. For development, for deployment, we took Streamlit as an app to support our required output. Making sure to avail the monitoring facility for new and unknown data point. With the user, we will be able to upload our new best prediction outcome. That's all from my side. I would like Master Nayan to take over for further.
Is my voice audible? Thanks, Deepak. Good evening, everyone. My name is Nayan Soni, and I am explaining about data understanding and data description. So let's understand data. Our aim is to recommend top 5 crops to farmer with return on investment. So here we have used two data sets. One is agri data and other one is crop ROI, which is in .csv format, which we have collected data from agricultural websites and journals. So first we talk about agri data. This dataset consists of 12 columns and 4,921 records. So here crop is our target variable and rest all are independent variables. Next slide, please. So here these are the metadata of crop recommendations. So if we look, we have three categorical variable and rest all are numeric variables. Next slide, please. So in crop ROI dataset consists of 13 columns and 4,921 records. And here our target variable is return on investment and rest all are independent variables. Next slide. So these are the metadata of crop return on investment. And here we have four categorical variables and rest all are numeric variables. Next slide. So here we have collected data from primary sources through journals, etc. And afterwards, basic cleaning and pre-processing steps were taken to standardize the data, remove null values, duplicate low variance, high correlated values, and afterwards we moved for EDA. Now I would like Muzammil to continue with the presentation.
Thank you, Nayan. Hi, I am Muzammil. I am going to explain EDA, Exploratory Data Analysis. EDA is the process of investigating the data to discover patterns and anomalize outliers and form hypotheses based on our understanding of our data set. Visualization is used to show the graphical representation of the data. By seeing visualization, everyone can understand. Frequency target feature crop recommendation. By seeing this plot, we can understand that rice has major contribution among all crops and peas has minor contribution among all crops. Next slide. Box plot. Box plot is used to find the outliers. There are three quartiles in it: interquartile, lower quartile, upper quartile, and we can see outliers in area, production, etc. Next slide, please. In nitrogen graph, we can see the distribution that the data is right skewed. In K potassium kilogram per hectare graph, we can see the distribution of the data is right skewed. In potassium graph, we can see the distribution of the data is right skewed, and also we can see some outliers in it. Next slide. In phosphate graph, we can see the distribution of the data right skewed and some outliers. In temperature graph, we can see the distribution of the data is left skewed. In rainfall graph, we can see the distribution of the data is slightly right skewed. In humidity graph, we can see the distribution of the data is left skewed. Next slide. In potential graph, we can see the distribution of the data is left skewed. Next slide. Return of investment. Return of investment is nothing but popular profitability metric used to evaluate how well an investment has performed, and we can see outliers in it. For example, crop duration, phosphorus, yields, etc. Thank you. Over to my friend Deepali.
Thank you, Muzammil. Good evening, everyone. I am Deepali Agarwal. I am explaining about the univariate plots of return on investment of crops. ROI is the percentage of return a farmer receives with respect of cost of cultivation. This data visualization helps us understand how the trends, outliers, and underlying patterns in the data. This bar graph represents the crop duration of the crops. We can draw inference that mostly crop duration lies between 50 to 150 days and data is normally distributed, but some outliers are present. Here, the left side bar graph represents the nitrogen value of soil. We can inference that data is not normally distributed and some outliers are present. And the right side bar graph represents the phosphorus value of soil. We can inference that data is not normally distributed and some outliers are present in the right side. Here, this left side bar graph represents the potassium value of soil. We can inference that data is not normally distributed and some outliers are present. And the right side bar graph represents the pH value of soil. We can inference that some outliers are present in the left side and data is not normally distributed. Here, this left side bar graph represents the yield bag per hectare. we can inference that data is normally distributed, and right side bar graph represents the how much seeds are used in per hectare. From this graph, we can inference that data is not normally distributed. And here, this left side bar graph represents the cost for cultivation. We can inference that data is not normally distributed. And the right side bar graph represents the net income from the crops. From this graph, we can inference that some outliers are present in the right side and the data is not normally distributed. Here, this left side bar graph represents the price of the crops. From this graph, we can inference that data is not normally distributed, and the right side bar graph represents the return on investment of the crops. From this graph, we can inference that some outliers are present and data is not normally distributed. That's all from my side. Further, I ask Tariq to carry the things forward. Thank you all.
Good evening, all. This is Tariq. I will walk you through with bivariate analysis. First, we need to understand what is bivariate analysis. Bivariate analysis means the analysis of bivariant data, which is two variables. The purpose of this analysis to determine the empirical relation between two variables. To understand this, we are using a scatter plot, and we have segregated crops with the different colors of color legends. All right, this slide shows the relationship between nitrogen and phosphorus with respect of crops, where nitrogen is in a low degree of positive correlation with phosphorus. Rice is high in nitrogen and phosphorus. Ginger crops is low in nitrogen and phosphorus. The pH versus potassium. Potassium is no relation with phosphorus. Here, sugarcane crops is high in potassium and pH. Cucumber crops is low in potassium and phosphorus. Rice crops is average in potassium and pH. Humidity versus rainfall. Rainfall is no correlation with humidity. All crops need average rainfall and humidity. Temperature versus area. Temperature is no correlation with area. Arhar and tur crops is high in temperature and low in area, where ginger crops is in low temperature and area. Rice crop is average in temperature and area. Area versus production. Production is in low degree of positive correlation with area. Cotton crops is high in area and low in production. Sugarcane crops is high in production and low in area, where wheat crops is low in production and area. Here, we are trying to show the correlations through heat map with all features, where we'll find if any of the features has high correlation, we try to take off or we have to make some adjustments. So the particular variables will not affect our model. Same we did for the crop recommendation and ROI. The heat map will reflect where the data is highly correlated or not. The next part, model building approach and features, will be explained by my teammate Akhil. Over to you, Akhil.
Thank you, Syed. My name is Tanneer Akhil. Coming to model approach and features. In our project, we used these many algorithms like KNN, SVC classifier, T random forest, XZ boosting, gradient boosting, stochastic gradient boosting, etc. Next slide. XZ boosting. The full form is extreme gradient boosting. Extreme gradient boosting is a gradient boosting library in Python. It is based on gradient boosting decision trees. It is a boosting algorithm which is used in various competitions like Kaggle for improving accuracy and robustness. Building models using XGBoosting is quite easy, but improving its efficiency is really hard. We have various parameters in XGBoosting which requires tuning like learning rate, maximum depth, N estimators, GB linear. The reasons behind to select it is highly flexible and parallel processing, regularization, handling missing values, tree pruning, built-in cross-validation. And XGBoosting also have good features like good bias variance trade-off and great computation speed. Coming to the metrics, accuracy, the ratio of correctly predicted observations to the total observations. Here, the test accuracy is 92.52 and train accuracy is 92.54. Precision, ratio of correctly predicted positive observations to the total predicted positive observations. Here we got 0.93. Recall or sensitivity, ratio of correctly predicted positive observations to the all observations in actual class. Here we got 0.91. Coming to F1 score. F1 score is weighted average of precision and recall. Therefore, this score takes both false positives and false negatives into account. F1 is as usually more useful than accuracy, especially if you have uneven class distribution. Here we got 0.92. Next slide. Next slide. XGBoosting regression. Here the parameters are gamma, learning rate, maximum depth, N estimators, regularization alpha, regularization lambda, verbosity, random state. These are we selected as features. Coming to the metrics, mean square error, MSE. It is basically calculation the difference between estimated value and actual value, and the XGB regressor score, that is RMSE value, root mean squared error. RMSE calculates the average squared errors across all samples, but in addition takes the square root of the result, effectively taking the square root of mean squared error. R score or coefficient of determination. R square represent the proportion of variance dependent variable y that is explained with the help of independent variable x. Further will be continued by Ritika. Thank you.
Thank you so much, Akhil, for letting us know about the model. So, hey everyone, I'm Ritika Verma. Now I will be telling you the working of this model, how it will take the input and how it will help the type of crop which we can grow. Here in the web page, we can design this module in which here you can see the screen where the calculation will help the farmer more suitable crop which they can grow. Okay, so here you can see a value of different minerals. Okay, of soil being entered, like if we enter 28, please pause. Yeah. If we enter 28 to nitrogen, and here we enter 25 to phosphorus, potassium to enter 29 value, coming to pH value. pH value with 7 and the humidity value like go with 30, and the rainfall in the area we enter 30 millimeter. Then we go with the temperature around the area 25 degrees Celsius, and then the area we consider 100 hectare. Now then the production we can enter 30 quintal. Then see the prediction will come. Okay, the prediction will come with such kind of soil with these features. So according to the prediction, rice is recommended crop and dry ginger is one of the recommendation. Jawar and brinjal, sugarcane are also recommendation crop in the field. And you know such kind of crop you can grow in such kind of features. So you know this will help us to the finding out what kind of crop grow. Now coming towards the future scope. As you can see, this application has a great future scope. So this web page will help the farmer in predicting the crop disease and prevention. You know, it will help the increasing their crop yield by applying the proper algorithm. We can achieve the higher yields of crop. And in the future time, we can also add different business language to this web page. And we can also add the features of sound in our web page. So those who cannot read and write. As if now we have just added the Telangana region in the web page, but later on we can also add different states of India. Coming towards the conclusion.
So by using this web page, farmer can easily detect and take a right decision. Presently, our farmers are not effectively using technologies and analyze. So there may be a chance of working wrong selections of crop for cultivation that will reduce their income. So to reduce those type of losses, we have developed a farmer-friendly web page that will predict which would be the best suitable crop for particular land. In agriculture, several data mining strategies are used and analyzed to predict the crop cultivation. This research has focused on comparing the feature selection method of different prediction models and suggests some best method to forecast crop cultivation in the future. Go to the reference, please. Okay. See, we have take these points in the reference from the website links. Links are mentioned here. You can also go through it. For the soil content, we have take these links and other website also. I think this is very well mentioned here. Thank you all. I hope our work has impressed you and it will helpful for the farmers. I would like to thank my mentors and our project manager for supporting us to thank throughout the process, and a big thank for to the team as well who can done a great job. Thank you. Now I will hand over to the next team.
Thank you for giving us this opportunity. Hello, good evening, everyone.
Is my screen visible?
Myself Neelam Gaikwad, and I am welcoming you to the project presentation by 360DigiTMG. The title of the project is Predictive Agriculture Analysis, which is designed to meet the expectations of agriculture analytics. The purpose of this document is to recommend the best crop and predict the price, especially for the predicting the crop, which gives less investment and high profit. Next. We would like to thank and happy to announce that we have completed our project under the guidance of Mr. Sharad Chandra, who is director at Innodatics of 360DigiTMG, and project manager is Mr. Raju. And next, also the mentorship of Emmanuel sir, Ashpak sir, and Gomati ma'am. Next. To start with, I would like to introduce the team members of our team. Pradipti, Juaria, Anushri, Sai, Kirtana, Sindhu, Sampat, Neha. It's me, Neelam. Next. Then we have Narendra, Maunika, Anil, Nagesh, Mohammed, Faizur, and last Pradnya. Next. The overall content of the project will cover by project goals and objective of the project, followed by business pipeline, technical stacks and architecture, data collection and extraction, data preparation, model building, project implementation video, and finally deployment output and conclusion. Thank you. Next, Juaria will take over.
Thank you, Neelam. Hi all, I'm Juaria, and I will be going over the project overview, objectives and constraints, and will also cover the business pipeline and technical stacks that we have used in our project. As we all know, agriculture in India plays a predominant role in economy and employment. The common problem that we have is that farmers don't choose the right crop based on their soil requirements, climatic conditions, and market trends. Due to this, it hits the productivity. To target this issue, we can use research data for soil types, crop yield, weather conditions, market trends, and suggest the farmers the right crop based on their site-specific parameters. In this case, it is Telangana region. With this in mind, we will look at our project objectives. It is to build an application that aims to maximize the crop yield and profits, minimize crop loss, to recommend optimum crops to be cultivated based on all these parameters and help farmers make an informed decision before cultivation. And here are some of the constraints that we faced during the project and foresee in the future. We face time constraints. Since the data collected is primary sourced, the time taken to gather the data was more. Considering all the aspects of investment, there could be less profits. The features considered are based on historic data, such as temperature, rainfall, and humidity. So there might be some inconsistency in the results. Coming to the business pipeline, in CRISP-ML methodology, first step is business and data understanding. Here we understand the objective and constraints of the project. Also, we take a look on our data and features that are involved. We will go through the feasibility of application, data collection, and data quality verification. Then we move to data preparation. Here we will work on feature selection. Then we will clean the data by using different modules of Python, where we need to do data pre-processing, and then we need to do model building, where we will build a model by using machine learning algorithms. Then we move to testing and evaluation phase of model, where we will check the performance of the model and robustness. Finally, we move to deployment part, where we will deploy the model to form an application by using different web framework. Then comes the monitoring and maintenance part, where we will monitor the application, and if there is some issue or upgrade that needs to be done, then we will go for maintenance. Technical stacks we have used: Python libraries such as sklearn, matplotlib, seaborn, etc. We have used pandas profiling. It's an open source Python module with which we can quickly do an exploratory data analysis with just few lines of code. It generates interactive reports in web format. And we have used Tableau for visualization. We have also used matplotlib, that is a cross-platform data visualization and graphical plotting library for Python and its numerical extension NumPy. As such, it offers a viable open source alternative to MATLAB. Python library sklearn is the most useful and robust library for machine learning in Python. It provides a selection of efficient tools for machine learning and statistical modeling, including classification, regression, clustering, etc. We have used Pickle for serializing and deserializing a Python object structure. That is the process whereby a Python object hierarchy is converted into a byte stream. We have used Jupyter Notebook, a web application for creating and sharing computational documents. It offers a simple, streamlined, document-centric experience for model building. We have used PyCharm, which is dedicated Python integrated development environment, providing a wide range of essential tools for Python developers, tightly integrated to create a convenient environment for productive Python web and data science development. Lastly, for model deployment purpose, we have used Streamlit. It's an open source app framework. It helps us create web apps for data science and machine learning in a short time. It is compatible with major Python libraries such as sklearn, pandas, matplotlib, etc. I will now be handing over to Pradipti to go over the architecture of our project.
Thank you, Suvarya. I'm Pradipti. Now I'm going to present project architecture or data pipeline. This showcases the entire workflow of our project. Project objective. Here we have to understand the main goal of our project. And then we have to understand the requirements of our project. Then we move to collect. Then we have to collect the data. Our data is primary data. That means it collected from internet or websites. After collecting, the data was merged using SQL. After that, we move to EDA part. Here we used pandas, NumPy, pandas profiling. Pandas profiling is an open source Python module. For visualizations, we used seaborn, matplotlib, and also used Tableau. Now we move to data preprocessing part. Here we have performed label encoding, outlier treatment, and missing values. Data set is imbalanced. So to balance our data set, we consider this mode technique. Next, supervised learning. Here we divided the train and test data into 80% and 20%. Next, we move to model building. Here we have considered classifier models. They are decision tree classifier, logistic multinomial classifier, navy-based classifier, KNN classifier, random forest classifier, support vector classifier. Now we move to model selection. Based on accuracies, precision, and F1 score, we selected SVC amongst all the models. After that, we perform hyperparameter tuning. Then we deploy the SVC by using Streamlit in Python. Lastly, we can save it in client servers for monitoring and maintenance purpose. Next slide. Data collection. The data is a primary source. Process of gathering data through internet, interviews, or websites belongs to Telangana government and etc. Price data set referred from government according to 2020 and 21. Using Tableau, prices have been forecasted. Merge the forecasted prices and crops in one data set. Next slide. Here, some of the aspects that we collected from Medak district during our data collection phase. The type of soils found in Medak region like red earth and black cotton, etc. These are the normal climatic conditions like rainfall, humidity, and temperature. The different sources of irrigation like canals, tanks, dug wells, bores or tube wells, etc. Here are some of the groundwater resources like groundwater availability, annual drops, and etc. Next. Here are the calculations for grass income. Forecasted price into yield is equal to gross income. Net profit per acre, gross income minus investment required is equal to net profit. Return of investment percentage. Net profit by investment required into 100 is equal to ROI. That we have considered. Thank you everyone. Next, Anusri will take over.
Thank you, Pradipti. Hi team, my name is Anushri and I'm going to present about data visualization and inferences. Next. So first plot is between crop and year. Here we are considering the years from 2017, 2018 and 2018 and 2019. Here the crop is grounded values of year and the main crops like paddy and maize count is more compared to the remaining crops in both the years. And second plot is between crop and season. The main seasons we are considering is Kharif and Rabi season. In the Kharif season, there are more crops grown compared to the Rabi. Next. Next plot is between crop and district name. The district name is ground values of crops where the Ranggareddy district has the highest margin. And the next plot is between crop and soil types. Out of the 4 main types of soil which we are considering, the majority of the crops are grown in sandy loam compared to the remaining. This is it from my side. From here, Sai Teja will continue. Thank you.
Thank you, Mr. This bar graph showcases return of investment versus initial investment. Here we have considered average of return of investment and average of investment required for each crop. As we can see in the graph, the return of investment for grapes and tomato hybrid is highest as compared to other crops. The bar graph showcases profit and investment. Here we have considered average of net profit and average of investment required for each crop. As we can see, the top 5 profitable crops are tomato hybrid, grapes, tomato, papaya, and pomegranate compared to other crops. and top 5 crops where the investment is least are cow gram, groundnut, black gram, bengal gram, and castor. Client can consider crops with less investment like tomato hybrid, grapes, and tomato, which gives highest profit among all. Thank you. Next, Mohammed will take over.
Thank you, Saiteja. Good evening, everyone. Myself, Muhammad. Now I am going to present data preparation of our data set. Data preparation is the process of gathering, combining, and structuring and organize the data for business intelligence. While working in data cleansing, we didn't found any duplicates in our data set. We had found there are lots of outliers in that we had to replace it, and no missing values found in our data set. We had used label encoding in our data preparation. So label encoding is nothing but converting the labels into numeric form as to convert them into machine readable form. Then we had to typecasted the values from our data, which was in float. We typecasted in integer because float values are not permissible. Next. Since our data is imbalanced, we had used smart technique to balance the data. So let's discuss about smart technique. Smart technique is synthetic minority oversampling technique. An oversampling technique generates synthetic samples from the minority class. It is used to obtain a synthetically class balanced or nearly class balanced training set, which is then used to train the classifier. Thank you. Now Anil will continue with the slides.
Thank you, Mohammed. My name is Anil Kumar Reddy. Now I am going to present the model building. As per our dataset, we have selected the classification of supervised learning algorithm. So here are the some models that we are used. Decision tree classifier, logistic multinomial classifier, Navi Bayes classifier, KNN classifier, random forest classifier, and SVC support vector classifier. And we have taken the train and split test split as 80 and 20%. Here we have note some of important points on decision tree. In addition, decision tree terminologies. Moreover, we can see here advantages and disadvantages of decision tree. Similarly, we have provided information on KNN. Thank you. Next, Nagesh will be take over.
Thank you, Anil. I am Nagesh, and now I'm going to continue presenting model description. SVC, Support Vector Classifier. In our model, we have opted for SVC model. The objective of a linear support vector classifier is to fit to the data you provide, returning a best fit hyperplane data. The algorithm creates a line or a hyperplane which separates the data into classes. Then coming to advantages of SVC. The SVC works relatively well when there is a clear margin of separation between classes. It is more effective in high dimensional spaces. It is effective in cases where the number of dimensions is greater than number of supplies. SVC is also relatively memory efficient. Then coming to some of the disadvantages of SVC, it does not perform very well when the data set has more noise, that is target classes are overlapping. We have noted some important key points for the following models: naive Bayes classifier, random forest classifier, logistic classifier. Next slide. Accuracy table. These are the different models which we have used in our model, and these are the train accuracy and test accuracy respectively, and precision, recall, and F1 score. Next slide. Since our data is imbalanced, we have considered precision, recall, and F1 score. This is for SVC model. The first column represents the crops. For example, crop 0 to 0.29 is the precision, 0.67 is the recall, and respective F1 score and accuracy. Next slide. Deployment strategy. Web deployment is used primarily in scenarios where developers use it for sync a compiled web application from developer tools to internet information services. So coming to our model, we have used Streamlit in PyCharm for development. deployment. Thank you. Next, Joaria will take over.
Thank you, Nagesh. I will quickly go over the code and the deployed model. We have loaded the data set here and generated a report for EDA using Pandas profiling. These are the columns that we have in our data set. And here we are getting the number of unique values in our data set and the data types that we have. We have 753 rows and 26 columns. Then we have performed our first moment business decision, followed by second, third, and fourth. This will be our data visualization for different features. Here we have used Matplotlib. Then we detected some outliers, which we have replaced it. Then we checked for some missing values and we did not find any null values in our data set. Then we dropped the columns that are not required. Then we applied label encoding for categorical data and then converting all the features to integer type. We have displayed the heat map to look at the visual summary of the information. Then we split the data into train and test, that is 80 and 20%. Since our data was imbalanced, we used SMOT technique to balance it out. And then we have applied different models. Amongst that, we have selected SVC for our application based on the accuracy, and we also calculated its F1 score since our data is imbalanced. So the closer the score is to 1, the better the model will be. And then we have generated pickle files for the model deployment. This is our deployed application. We have provided the required fields for the client to enter the values of season, district name. We'll enter the NPK values. We'll be entering the temperature, humidity, rainfall, and the pH value. We enter these values and hit the get recommendation button. And we get a list of crops to be cultivated along with the return of investment percentage and yield per acre in quintals. Thank you. I will now hand it over to Sindhu to conclude the presentation.
Thank you, Julia. I will go over the future scope now. Now, coming to this future scope, we have developed this model based on the primary resources available, and we have provided the data. So in future, by obtaining the accurate data, we can improve the accuracy of the recommendations, as now we have taken the primary and the secondary sources. So this can be taken into future scope. Next, this helps in evolving the hybridization to the farmers, like based on the various parameters, the farmers can choose the best crop in their location. Also, we can use this system in providing more suggestions to the farmers, which will be very helpful in improving the ROI, and also techniques in getting better returns with less investment can also be achieved. Now, I would move to the conclusion. There are few crops and areas where we get more investment from limited resources. So we have identified that, and we have provided the recommendations from our recommendation system. And also we identified that climatic conditions and soil type are proportionally influencing the crop and the various income generated sources. So our recommendation helps in identifying those useful data to the farmers very well. Also, our farmers can use this system in improvising the methodologies and grow crops, which indirectly will be increasing the economy of our country. This is all what from our team. Now I'm very happily handovering it to the team C. Team C, can you go forward?
Yeah, thank you guys. Thank you so much. We will take it forward. Okay. Thank you. First of all, thank you 360DigiTMG for giving this opportunity. Good evening, one and all. Myself, Praveen Kumar, and welcome to 360DigiTMG YouTube channel. Today's presentation is about predictive agriculture analytics. So in this project, we are trying to predict the best crops that can be cultivated in the presentation. Sorry, in the respective month as per the farmer wish. These are the team mentors who helped us in development and even in data collection and in every part of the project. We have Mr. Sharath Manikonda. He is the director of InnoDataTex. We have Raju Kalyan. We have Ashfaq Sheikh. We have Gomati Chakravarti and Emmanuel Mitra, who are the project mentors for our project. To start with, I would like to introduce my team members. We have Vismaya MK, we have Sai Surya, we have K Gayatri, we have Asma Shaheen, and this is myself, Praveen Kumar. We have Suprita and Madan Kumar. The overall content of the project will cover introduction to agriculture, project overview and goals, business pipeline, technical stacks, that is tools and techniques which we have used in the project, architecture of the project, data collection, and EDA. EDA is about exploratory data analysis, data pre-processing and visualization, model building, selection of model and deployment of the model, working of deployment model. Then we have an output to show how the model predicts the crop, future scope of the project, and finally conclusion of the project. To start with the introduction part, agriculture is a main occupation in India. Like we know, 2/3 of population is dependent on agriculture directly or indirectly. So when it comes to Telangana, agriculture plays a major role in economy income. It has a large landscape with a different type of weather conditions, which helps growing a variety of crops. As we can see, around 1.06 crore hectares is under agriculture, in which farmers can grow all type of crops. For example, fruits, spices, vegetables, flowers, medicinal and aromatic crops. Rice is a major crop which can be grown here. With rice, we have many locally grown crops like cotton, sugarcane, mango, tobacco, sunflower, and peanuts as well. Although we can grow many crops, farmers are not able to get more profit due to many reasons like poor production, poor returns, and there will be many more reasons for that. As we all know, many farmers are committing suicide and they're not able to get the profit which they were expecting, and it is becoming a major issue. So let me tell you some of the reasons why there will be agricultural loss. First will be less use of technology, mechanization, and poor productivity. There might be a lack in usage of technology or lack on mechanism that they are using to grow the crop, which leads to poor or less productivity. So the next point will be poor infrastructure for farming, making more dependent on weather, marketing, and supply chain. Weather also plays a major role to get the best productivity. But if the weather condition is not good, and if there is an unexpected change which might lead to loss of crop, marketing and supply chain also plays a major role, and it's also a major reason for the farmers going on loss. And there might be no effective marketing, or there might be no better supply chain. And the next point will be the no predictive knowledge of marketing price, probable yield, profit for selecting best crop. In many cases, farmers might not be aware of exact market price for the crop or how much yield they have got for the particular acres of land, or in choosing the best crop as per the climate and the soil conditions. So how do farmers come out of this loss, and how do farmers get to know to choose the crop depending upon the soil conditions or the climate conditions? To overcome the IBO issues, we have come up with a model which helps farmers in smart farming. Smart farming helps farmers in agriculture to know which crop to grow as per the type of climate and the type of soil, or as per the humidity in the climate. These all are the aspects are collected and loaded to our data set to get the best crop suggestion as an output. As we all know, machine learning is a technique that that is growing drastically in the model technical world. This machine learning can be used to know crop features and suggest the best crop which can be sown. We can predict the future yield, market price, cost of cultivation, and profit per crop, which helps farmers to make decisions to choose the best crop using data analysis. Our project helps farmers to in choosing the best crop to get the best yield with maximum profit. We'll move to next slide. Let's move on to goals of the project. As like all the projects and ideas, we have both objectives and constraints. Firstly, we will look on to objectives of the project. We will be building a web application for recommending the best crop that can be cultivated by farmers based on several parameters, and to make sure farmers will get the profit by recommending the best crop. Then in constraints, as we all know, no one can predict the exact climate conditions. So this model may get impacted by unforeseen conditions like rainfall, drought, or other natural calamities. Next, we cannot predict the market price of the crop. It might vary as per the supply and the demand in the market. Next, we have no 100% accuracy in prediction, because if we take 100% prediction, 100% accuracy in prediction, if the data changes, the results might vary. Then we have cannot work with live data, because live data is not available, because this model we cannot work with the live data. We have to take the data from other sources. We have to load it our data set. Then our model will help us in predicting the crop. So I will hand over the next part to Asma Shaheen. She will explain much more about this. Asma, hand it over to you.
Thank you, Praveen. Hello, everyone. I'm Asma, and I'm going to explain about the business pipeline, that is CRISP-ML methodology. The cross-industry standard process for data mining is a process model with 6 phases that describes the data science life cycle. It helps to plan, organize, and implement the data science project. The first step is business and data understanding. This is understanding business needs and to understand what data do we have or need. Is it clean or not? The next step is data engineering or data preparation. This is understanding how we organize the data for modeling. The third step is model building. It helps to understand what modeling techniques should we apply. The next one is model testing and evaluation. It helps to understand which model best meets the business objective. Finally, there is the deployment. This is process that helps the end user to access its results. Model monitoring is an operational stage in the machine learning lifecycle that comes after model deployment. It entails monitoring your ML models for changes such as model degradation, data drift, and concept drift, and ensuring that your model is maintaining an acceptable level of performance. Maintenance can be defined as an effort taken to keep the condition and performance of a machine always like the condition and performance of the machine when it was still new. Coming to the next slide, it's about technical stacks. In technical stacks, we have a collection of technologies or softwares used during the course of the project. Here we use Spydo for the deployment, Tableau for the visualization process, Pandas profiling is an open source Python model with which we can quickly do an exploratory data analysis with just a few lines of code. Streamlit library is used to deploy the model. Python pickle model is used for serializing and deserializing Python object structure. Any object in Python can be pickled so that it can be saved on disk. What pickle does is that it serializes the object first before writing to its file. Pickling is a way to convert a Python object into a character stream. The idea is that the character stream contains all the information necessary to reconstruct the object in another Python script. Jupyter is used for modeling. NumPy, which stands for Numerical Python, is a library consisting of multidimensional array objects and a collection of routines for processing those arrays. Using NumPy, mathematical and logical operations on arrays can be performed. Scikit-learn or sklearn provides a selection of efficient tools for machine learning and statistical modeling, including classification, regression, clustering, and dimensionality reduction via consistent interface in Python. Pandas is a Python library used for working with datasets. It has functions for analyzing, cleaning, exploring, and manipulating data. Seaborn is a Python data visualization library based on Matplotlib. It provides a high-level interface for drawing attractive and informative statistical graphs. Next, I'm going to explain about the project architecture. Next slide, please. First step is business and data understanding. Here we understood what business is all about. It is a farming project wherein best crops are recommended to the farmers. Next, we understood project objectives and constraints. Project objective is to build a web app for recommending the best crops to the farmers based on several factors. The project constraint is that this model may get impacted by unforeseen conditions like rainfall, droughts, and other natural calamities, and the market price may not stay static and it keeps fluctuating from time to time. The third step is data collection. We collected the yearly crop data from various government sites and imported it into the Excel sheet. The data is then cleaned by using pandas profiling. Next, the data is visualized by various plots to draw insights from the collected data. Here we use various visualization tools such as Matplotlib library, Plotly, Seaborn, and Tableau software tool. Multiple models are built such as random forest, KNN, logistic regression, naive-based decision tree, XGBoost, and SVM. All these models are evaluated by using accuracy, precision, recall, sensitivity, and F1 scores. Finally, SVM model is chosen that has the best accuracy. This model is deployed to create a web app using the Streamlit library. This way, best crops are recommended to the farmers. Finally, the deployed model is continuously monitored and maintained by tracking and analyzing production model performance to ensure acceptable quality. Thank you. The next part will be taken by Suprita.
Thank you, Asma, for giving a clear picture on technical stacks and project architecture. Hi, everyone. I'm Suprita, and I'll be explaining about data collection. Next slide. Data collection is the basic step in machine learning, and it is the most important step as it allows us to capture a record of past events. It is also very important to maintain quality data for any model to operate efficiently. So we have collected our data majorly from telangana.gov.in and other different sources like PDF, literature, reviews, and all. Few inputs were also collected from client, and finally we combined everything into a single Excel file. Shape of our data is 1800,27. The features that we have considered in our data set is given below. First one is district. Our data is all about Medak district of Telangana. And we have worked on monthly data for the year 2019, 20, and 21. So coming to crop types and crops and its types, there are 50 different crops that we have considered, and they are divided into 6 different types as shown in the diagram. Next slide. So the next one is crop zone. It represents the best month in which the crop can be sown. We have put it as 1 and 0 for the crop that is being sown and not sown respectively. For example, if you see the bar graph for bajra crop in the month ranging from May to September, so these are the best crops these are the best months for which bajra can be sown. Empty graph or empty space denotes that there's no crop sown in that particular month. Next slide. So coming to weather parameters, With up parameters is very important to gain the maximum yield. So the parameters that we have considered are temperature, humidity, wind speed, and rainfall. First graph represents humidity versus temperature according to the month, and the second graph represents rainfall versus wind speed based on the month. Next. Next slide. Yeah. So the next feature is crop yield. It represents the quantity of crop in kg that is being harvested per acre. If you see the graph, you can notice that capsicum has got maximum yield, whereas sunflower has minimum yield. Next. Cost of cultivation. So it is the total expenses incurred for cultivating 1 acre of crop. It includes labor costs, fertilizers, pesticides, irrigation costs, and all. So if you see the graph, avocado, dates, dragon fruit has maximum cost of cultivation because they are usually long-term crops. So they require long-term maintenance. Next. So our next feature is MRP. It is the maximum price that can be charged for any crop. From the graph, it is very clear that jasmine has got highest and sugarcane has least MRP. Next. Gross income and net profit. So in simple words, gross income is the total earning a farmer receives before any deduction. It is given by gross income equals yield into crop zone into MRP. So the net profit is the total amount of profit obtained after reducing all the expenses from gross income. It is given by net profit equals gross income minus cost of cultivation into crop zone. ROI, return of investment, it is the percentage of return a farmer receives with respect to cost of cultivation. And it is given by the formula ROI equals net profit by cost of cultivation into 100. Next slide. Soil parameters. So it mainly includes soil type and its pH. The soil is very important for crop because it is the main source of water and nutrients, and it also provides physical support. So the bar graph represents soil type and its average pH that is seen in Medak district for the crops that we have chosen. And NPK value simply denotes the amount of nitrogen, phosphorus, and potassium required in the fertilizers. Next. Crop duration. So it is the time span between sow and harvest of a crop. It simply denotes the time required for the crop yield. So we have divided the crop into small, intermediate, and long-term crops. Crops that can be harvested within 3 months are short-term, and if it takes more than 3 months, that is in between 3 to 12 months, it is intermediate, and if it exceeds 12 months, then it is considered as long-term crops. Next slide. So next one is sow and harvest. This simply represents how many times the crop can be harvested once it is sown. For example, if you see the third diagram, paddy, wheat can be harvested only once per sow. But if you look at the second one, dates, avocado, and all, they can be harvested n number of times once the crop is being sown. Same thing for the first diagram, that is one sow, few harvest. So coming to irrigation, irrigation is very essential because rainfall is not uniformly distributed in Medak. And there is also a water crisis. And it also depends on the type of fruit that the crop has. Crops such as coconut, mango has got taproot system, so they have an ability to go deep into the soil surface and absorb the water. So they do not require irrigation. Whereas if you look at paddy, maize, they possess adventitious roots. So these roots do not grow into the surface, and for sure they need irrigation. Next slide. So finally, we've got a column to represent best mixed cropping combinations. Mixed cropping combination is useful because it increases soil fertility, crop yield, and also reduces the cost of cultivation. If your main crop is long term and you can't wait for so long to get the profit. So if you choose mixed cropping, you can be earning while your secondary crop is giving the yield. So to find the best possible crop combinations, we have used association rules. In the graph, you can see that Jowar has maximum count. So this crop can be combined with maximum crop that is present in our data set. Next slide. So this graph represents the crop combination based on the support. Here, consequence are the primary crops and accidents are the secondary crops. For example, if you take chilies as a primary crop, the possible secondary combinations are tomato, ginger, coconut, marigold, and jasmine. But the support is maximum for tomato, so tomato is the best secondary crop that can be mixed with chilies. Next. Yeah, that's it from my side, and EDA will be explained by Gayatri.
Thank you, Suprita. And I'm going to explain about EDA. Exploratory data analysis refers to the critical process of performing initial investigations on data, so as to discover patterns, to spot anomalies, to test hypotheses, and to check assumptions with the help of summary statistics and graphical representations. Next slide. Here we did a pandas profiling, and the overview of that is we have 28 features, 1800 observations in our data, and there is no missing cells and duplicate rows. And this data contains 10 categorical and 70 numeric and 1 Boolean column. Next slide, please. Heat map. Heat map is a graphical representation of data that uses a system of color coding to represent different values. It depicts values from main variable of interest across two axis variable as a grid of colored squares. Red color indicates negative correlation and blue color indicates the positive correlation. Each square shows the correlation between the variables on each axis. Correlation ranges from -1 to +1. Values closer to 0 means there is no linear trend between the two variables. The close to 1, the correlation is the more positively correlated they are, that is, and one increases as does the other, and the closer to 1, the stronger the relationship is. As correlation closer to -1 is similar, but instead of both increasing, one variable will decrease as the other increases. The diagonals are all one dark blue because those squares are correlating each variable to itself. So it is perfect correlation. For the rest, the larger the number and the darker the color, the higher the correlation between the two variables. The plot is also symmetrical about the diagonal since the same two variables are being paired together in those squares. Next slide. Pair plot. And this pair plot is also called as scatter plot matrix. Pair plot shows the relationship for combination of variable in the data frame for matrix of plots. Diagonal plots are all univariate plots. The pair plot builds on two basic figures, the histogram and the scatter plot. The histogram on the diagonal allows us to see the distribution of single variable, while the scatter plot on the upper and lower triangles show the relationship between two variables. Next slide. Data preprocessing. Data preprocessing is the concept of changing raw data into clean data set. The data set is preprocessed in order to check the missing values, noisy data, and the other inconsistencies before executing the ML algorithm. And the following techniques are used in this. Data is balanced with 36 value count of each output variable. And as I said earlier, there is no missing data and duplicate values. For categorical encoding, we used label encoding to replace the categorical values into numerical values between 0 to and the number of classes -1. For future scaling, normalization technique is used. And for this, we used formula x normalization is equal to x minus x minimum by x maximum minus x minimum. Here we did not use any outlier treatment because the data is unique. For further process, we need same data and the data was retained. Thank you. And the next will be handled by Sai Surya.
Yeah, thank you, Gayatri. I am Sai Surya, going to explain about data visualization. As we get a clear understanding from the previous slides about introduction and data collection and EDA, in the upcoming slides, we are going to discuss about data visualization. Data visualization is where we can see the pictorial or graphical representation of the collected data. Generally, when we saw the raw data, we cannot understand the clear picture of the data. So we go for data visualization for understanding more about the data. Yeah, in this visualization, we are going to get a clear picture of ROI based on crop type and crop term. As my teammate said in previous slide, ROI means return of investment, which means percentage of return a farmer receives with respect to cost of cultivation. The crops are divided into short-term, intermediate term, and long-term crops based on agriculture cycle of how long does a crop takes to cultivate fully from the time of sowing. The crops less than 3 months are classified as short-term crops. The crops between 3 to 12 months are classified as intermediate crops, and about 12 months are classified as long-term crops. In this visualization, average ROI with respect to crop type and crop term are shown. When we see intermediate crops, in fruit, mulberry gives us more ROI, and whereas banana gives us less ROI. And in vegetable, brinjal gives us more ROI and ginger gives us less ROI. Jasmine is the only flavor in the intermediate crop. By seeing this representation, we can easily say that among all the crop types, in fruits, mulberry gives us more ROI when compared to in grains, Bengal gram gives us less ROI. When coming to long-term crops, fruit is the only long-term crop because only fruit crops takes more than 12 months time. Among them, pomegranate has high ROI, whereas sugarcane has less ROI. When we come to short-term crops, in vegetables, onion has more ROI and paddy in grains has less ROI. And for the remaining crops are in is shown in the visualization. When we move on to next slide, in this slide, we are going to see the data of crops for net profit and yield has been visualized. The profit a farmer can get after deducting all the expenses to grow the crop is known as net profit. Net profit is expressed in rupees per acre. The harvested production per unit harvested area is known as crop yield. It is expressed in terms of kg per acre. Net profit has been divided from lower to highest profit of crops, which among them gingerly gives us less profit, whereas dates gives us more profit, but dates has less yield. When comes to yield, among all the crops, gingerly has less yield and sugarcane has good yield but very less profit. When moving on to next slide, in this visualization shows us the profit comparison of all crop types. The size represents the profit in rupees per acre and each color represents the different crop terms. Among all those, oil seeds has less profit, whereas the profit is maximum for fruits that belong to long-term crops. Remaining all crop types belong to short-term and intermediate term. As we discussed earlier, fruit is the only long-term crop. Each crop type with different shape and different crop term has been showed in this slide. When moving on to next slide. Next slide, please. Yeah. In the previous ROI slide, the crop type and crop term has been shown with different. In this slide, the ROI according to month is shown. Among all the crops, June and July month, mulberry has more ROI, whereas ragi in December has less ROI. This graph depicts the ROI percentage with respect to the sown month of the crop. Yeah, thank you. From here, Vismaya will continue.
Thank you, Sai Surya. Myself, Vismaya. Next. Next slide. I'm continuing from model building. Next. Next slide. As this is a classification problem, we have chosen classification models. Here are the few of models which we worked on. Decision tree. It classifies data into tree-like structure where internal node represents test attribute, branch represents test outcome, and leaf node represents class label. Random forest is an ensemble model of decision tree. A support vector machine creates a decision boundary which segregates data into different classes with which new data can be easily segregated. K nearest neighbor, when new data is passed into model for prediction, new data points are compared with trained data and prediction for new data point is done based on the similarity with the points in training set. Naive Bayes classifies data based on the conditional probability value. And logistic regression classifies data using log function. Multinomial regression is similar to logistic regression and used for categorical multiple output problems. Next. This is the description of model. We have put parameters like test accuracy, train accuracy, precision, recall, specificity, and F1 ratio for each model. We worked on the models, and these parameters are very important when we select the model for the deployment. Model which has optimum value is selected for the deployment. Next. Next. Okay. We chose SVM, previous slide. We chose SVM polynomial kernel for our deployment because it had a good value for all the parameters when compared to the decision tree model, which showed a overfitting value for the parameters. SVM had test accuracy 92.14%, train accuracy 94.37%, precision 94%, recall 92%, specificity 8%, and F1 ratio 92%. SVM polynomial is a nonlinear SVM model which uses kernel concept. Here, kernel's function is to map low-dimensional input space and transform it into high-dimensional space. Kernel represents similarity of training sample vector in feature space. The formula shown here is a kernel formula, and where k of xi, xj is a kernel function, xi and xj are vectors of feature space, and d is a degree of polynomial function. Degree parameter finds the optimum value in each data set, and default value is 2. Because when D increases, accuracy will fluctuate and system is less stable. Next. Model deployment, we used a web-based deployment method. Next. Web-based deployment is the process of deploying the code from source control to a hosting platform. We use Streamlit library for our app deployment. Streamlit is an open source app framework for data science project. Next. Next. This is the video of our deployment model. Play. This is the deployment code, and this is the link when we get when we run the code. This is our app which recommends crop based on the month we select. When we select the month, it shows top 10 crops with respect to ROI, which can be grown in that month. And also we have added other features like cost of cultivation and yield, which would help farmer to choose the crop he needs to grow. And also we have put filters, which will help him to filter the main data. For example, crop type. If he wants only fruit and vegetable, he can remove flowers and get only fruit and vegetable data. In the same way, if you want only fruit data, I can remove vegetable and get only fruit data. In the same way, we have added other filters like soil type, crop term, crop duration, and cost of cultivation. We have also put up a graph which compares cost of cultivation and profit with the crops grown in the selected month. This is the plot, and here orange color represents net profit and blue color represents cost of cultivation. We have also put up mixed cropping combination if farmer likes to do mixed cropping. This is the main crops grown in the month we selected, and these are the crop combination which can be grown along with the main crops. Hope you like the recommendation. Next. These are the outputs of our model deployed. Next. This is also the output. Next. Future scope. In coming years, we can work on data independent system with the same accuracy. We can also interface this app with multi-skilled app, and also we can collect more relevant features which would increase the accuracy of our model. We can also provide fertilization calendar and guidelines which would help farmer to know about the technology. We can use IoT devices to get live data, and also we can automate the processes like water supply, soil nutrient, minerals, and moisture checking using sensors. And this progress in agribusiness helps the farmers in production of crops, which gives them high yield and profit. Next. Conclusion, nowadays technology is being used in every field, but farmers are not effectively using that because of lack of knowledge in that. So we have to educate them about the technology. So to do that, we have developed a web-based app which is developed using SVM polynomial model, which gives a recommendation for top 10 crops and their ideal feature that has to be maintained to get maximum profit, among which they can choose best crop he wanted to grow. It also helps in finding best combinations of crops for mixed cropping. From this, if though the rancher is at home, he can work at the instant and there is no loss seen ahead. From this, we can conclude that this model is one of the best model which is useful in present world, which will be helpful, more beneficial for growing farmers economically to gain more profit and yield. Next. Thank you. Thank you for everyone, 360DigiTMG and InnoDataTech for giving us the opportunity to work on the project. If anyone has any queries, put up in the chat box, we will answer it.
Thank you, Vismaya, and thank you, team, for sharing all the info. So if anyone has any queries about the project, about the presentation, you guys can ask in the chat. Okay, I see I'm not able to find, I see there are no questions. So thank you guys. Thank you for giving this opportunity to show our talent and our presentation. Thank you.